Hey guys, today I'll be doing lead code 102 level order traversal. It is a medium question on lead code and it requires the BFS pattern. Now what does level order traversal mean? I've already talked about the basic tree traversal in another video, but what is level order traversal? The tree traversal, by the way, covers post, pre and in. But what is level order traversal? And these are more suited for DFS algorithms. Yep. So what is level order traversal? Now, if you look at this tree, right? 1, 2, 3, 4, 5, 6, 7. What we are supposed to do is go level by level. So layer by layer and print out all of the nodes that form at that specific layer. So you can see how 1 is in its own layer, how 2 and 3 are in their own layer, so they get a separate bracket, and 4, 5, 6 and 7 are in their own layer, so they get a separate bracket. Now that's what we're trying to replicate. And the thing with the BFS is the reference search pattern. This is just something you have to learn. It's that we will primarily use the key. So if you don't know the key, then you should look into priority queues and heap. But if you do know queue, then you know about the idea of having a first in first out structure, where if you have 1, 2, 3 lined up, then you will pop 1, then you'll pop 2, then you'll pop 3, and this is different from the stack, so it's not the same. We call this first in first out. Yes. So now BFS, like, it always has to do with the queue. And what do we put in the queue, right? Since you're supposed to traverse the array, this is just something you need to know. So I won't like explain why or like the intuition behind it. You just need to know this. If you have the Python library, then you can call dequeue on your root, and this initializes a key with 1, like the node 1 being the one inside of it. It still retains all of the attributes like the left and the right and the value, right? When you do pop it, you still have access to these. You're not storing the number 1, you're storing the reference to the node itself in your queue. So at the start, our queue will look something like this, right? 1. Now the part that actually the independent thinking comes in to is, if you notice that we start off with 1, then if we pop off 1, so if we take 1 out, right, we cut it out. If we pop off and we add its children, then we land on 2 and 3. And if we take them out, cut them out, and we add their children, so 4, 5, 6 and 7, and if we were to continue this, since we've already hit the end, it will just come to null next time, and that won't really matter. But we've hit the end, right? What I want you to notice here is that for every element in the queue, what we did was pop it off first in order to get the second part, right? Like the one after. We had to pop off 1 to get 2 and 3. We wouldn't get 2 and 3 by themselves. We would have to pop off 1, then we would get the children, we would get 2, 3. Then in a process, you would do 2, you would pop off 2, you would get 4, you would get 5. Then you would pop off 3 and you would get 6 and you would get 7, because that's the children. So if I put it into words, it's basically like, for every element inside of the queue, you will pop off the element for it, right? And you'll add the children immediately. But the emphasis is on the fact that you have to pop every element and then you add the child, so that the next iteration basically has the next level. Because if you see this pattern, it is the same exact one that I was showing you, and that's the answer, right? And it's basically just that for DFS. It doesn't, I mean, I guess more complicated than this, but this is like the template that you need to understand, having a queue and why popping of each element works to get you the level. So now to put it in code, because we are supposed to print out a results list, I'll show you what I mean. So our base case is if we don't have any if the root given is none, then our result will be empty. Now we make a result, and I'll make a queue called the queue, and I'll dequeue the root in it, right? We'll pass in the reference, so we still have the values. And while the queue is not empty, that means we still have nodes to process, right? Otherwise, if there were no nodes to process, you can just terminate it simply. Now we build our temporary list, right? Because we had to put a list inside of a list for every level, 1, 2, 3, right? So we'll make a temporary list, and now the main idea comes in. For basically I in range len q, right? So for the entire queue, you will basically just do node, and then you will pop from the left, because it is a first in first out, right? You'll pop from the left, so you'll pop 1, then you'll pop 2 next time, then you'll pop 3, then you'll pop 4, then 5, then 6 and 7, right? So you'll have to pop left, you'll check if the node actually exists, because sometimes you can have, like, let's say 4 was missing here, then this would be shown as null. It would still be added if we don't have safeguards, and you can just nullify that by just saying if it is not null, then only do some processing. Then we'll do, because we're already at the level that we want to be right now, we'll just simply add the nodes value. Then only would we add the children, so q.append, it doesn't matter what, like, the order that you put it, the right or the left. I would suggest doing node.left, node.right, just because it makes more sense. I don't think the order really matters. You'd just be traversing in the opposite direction, which would be odd, so I would say do left and then right. And if you're done with this, right, if you're finished popping of the nodes, like let's say 1 was finished, what was on level 1? It was only 1, right? So could we say that after we've popped every node from the list, we've essentially completed that level and we should move on to the next? Yes, we should, because as soon as we pop off 2 and 3 as well, we've hit 4, 5, 6, 7, which is the next level. So simply, if we are outside of the loop, then we've completed a level. Since we're outside of this, I'll write it over here, level over. And since level is over, this temporary value we used, we can simply just do if temp res.append this temp. Alright, and we will simply just return rs. Now why if temp? Sometimes the thing could just be empty, right? Because you could have the first ever, so you would just have this, or you could actually just have a bunch of nulls. I think, yeah, if you just had a bunch of nulls, no, actually you could have cases where if temp, I think this was an edge case that I implemented after I did the test case solving, and then I found that having this condition was important. Can I think of a reason why? temp.append node.val. I think it was because at some cases the temp turns out to be empty after this whole loop. I don't remember which ones off the top of my head. Give it a thought. But yeah, I think the safeguard is necessary, and that's it basically. That's how you